Okay, here is 2009, and it's going to be question number 3. And you have a set of rails with a metal rod. There's a string that pulls the rod to the right at a speed of 1.8 meters per second. There's some friction there. And there's a resistor. The distance from here to here is 0.52, so the length of the rod that's rubbing down the tracks is 0.52 meters. So they give you all that information, and then they say, first of all, calculate the magnitude of the current induced in the loop by the rod, the rails, and the resistor. So I said, let me think about how I could do that. And if I can find my work, there it is. I said, okay, for part A. I said in part A, the I is equal to V over R. But I've got to find the EMF. So the EMF is equal to BLV. The field strength was 0.80 Tesla. The length of the rod being pulled was 0.52 meters. And the velocity at which it moved was 1.8 meters per second. So I found the EMF to be 0.75 volts. And then I said, well, I is going to equal V over R, so 0.25 amps. That's part A. Okay, then I went to part B, calculate the magnitude of the force. I'm going to go at a constant speed, so I know all my force has to be balanced, all right? But I have some trouble because this time I threw in some friction, so they're going to see, does this person understand friction? So I said, well, the force applied has to be equal to the magnetic force plus the force exerted to overcome friction. So I said, well, the force applied, all right, the magnetic force is BIL, sine theta, and sine theta is sine of 90, plus mu times my force normal. So that's the force that I had to exert to move it at a constant speed. So B was 0.80 Tesla. My current was 1/4 of an amp. The length of my rod was 0.52 meters. And then my friction was 0.3 for mu. Times my force normal. My force normal was 0.22 times 9.8. And if I had a calculator out, which I do, I would multiply because I'm running out of space up there, 0.22 times 9.8. And I would get 2.156 newtons. 2.156 newtons for my weight, my force normal. So then my force applied would be the sum of those two, and I got 0.54 newtons for my force applied. I'm going to stop and check and make sure I didn't make a mistake. Okay, I checked my math again. It was all good. So that was part B. Part C said find the energy dissipated. So I said, let me think about that. Well, the energy dissipated is power times time. And power times time is the same thing as the voltage times the current multiplied by time. So energy is power times time. The voltage we said was 0.75. The current was 0.25. We're going to let this run for 2 seconds. So we're going to get 0.375 joules as our energy. Okay. And then part, so that was C. And D said find out the work done by the applied force. So force applied times the, said force applied times the velocity. So that's power right there, times time would be equal to the work done. So since I already knew my force applied was 0.54, and I was moving it at 1.8 meters per second, and I did that for 2 seconds, I wound up with 3.6 meters times 0.54, and I got 1.93 joules for part G. And then part E, if you look at part E, it said, compare your answers to C and D. Provide a physical explanation for why they are equal or unequal. I said that D was greater than C because energy or work was done to overcome friction. So that one seemed like it was pretty straightforward. All right, so I'm going to stop there.